Okay, we are live, you guys. It is Friday morning. What's the date? Gosh, it's crazy when you get caught up in this. The 20th. Spring is here. So 3/20/2020. So the first thing I'm going to do is show you yesterday's homework answers. Now again, you've got to show me work. No work, no credit, because it'd be easy just to write these down. But number 2 is 3/1. 4 is 3, -2. 6 was -1, -2. 8 was 1/2, 4. 10 was 6, 7. 12 was 1, 1/2. 14 is a -1, 2. 16 is a -1, -1. And 18 is a 1/4, comma, -1/4. So, like I've been telling all the kids, if there's a problem you don't get, text me or email me, and I'll show it on the film on how to do it. I've got some kids in geometry that want me to do that. I'm going to do that today. So if you're confused, let me know, okay? All right. So what's today's lesson? Well, before I do that, I will put up homework on the grade book when this unit's done. And it will really, if you've been doing everything, it will really help your grade, because I'm going to put it in as a test grade. And it's an easy A. If you haven't been doing it, you're going to get an F on that test grade, so it's going to be a kind of a bummer. So hopefully you'll do it. So what's today's lessons today? Okay, so today's lesson deals with these 3 pictures. Okay, all right, here they are. So it's possible that 2 lines will intersect, and this is mostly what we've been doing, is to make sure we find out where they intersect. And we've been doing it from either, by graphing, by the substitution method, or the elimination method. Okay, but this is an example of these 2 equations that intersect in a single point. Okay, so that is an answer, has 1 solution. Okay, second thing is if they're 2 parallel lines. And how do we know they're parallel lines? They'll have the same slope, but if they're parallel, they'll never intersect. Okay, so these 2 equations, if we were to do the problem, which we will, we'll get no solution. Okay, and then finally 3. These 2 equations are the exact same equation. So what we get is 2 different lines, but the 2 lines happen to be the same line. So in a sense, we graph one, and we graph the second line. So we got line 1 and line 2. Graph line 1, graph 2, and in that case, then we've got the same line twice. So where do they intersect? They intersect everywhere. They intersect everywhere. So then we'll say that it has infinite many solutions. Okay, now let's just take a look at what we have. So today I want to do a couple different examples. Okay, so first of all, let's take a look at example 1. Okay, here's example 1. So if I have y equals 5/3 x plus 1 and y equals a 5/3 x minus 1. Okay, if I take a look at these 2 lines, I already know that they're parallel. And I'm going to graph it anyway, but I already know they're parallel because they have the same slope. Okay, so I know if they have the same slope, that they are parallel. If they're parallel, they will not intersect, not at all, so there's no solution. I know that, okay? And I'm going to graph it anyway. In this case, kids might not graph it and say, well, gosh, Mr. Davies, I don't need to graph this. It's too easy. Okay, I agree with that, but I'm going to graph it anyway. Okay, so let me go ahead and take a look. And I'm going to graph them so you can see it anyway. So I'm going to graph the first one, equation 1. I'd start at 1. And I'd go up 5. 1, 2, 3, 4, 5 over 1, 2, 3. 2, 3, 4, 5, 1, 2, 3. Okay, with a little luck, got a ruler in here somewhere. Yeah, a ruler here somewhere. Just have to find it. Okay, I'll let you guys catch up while I'm looking for my ruler. Alright. What do I have that I can graph this with? Well, alright. It's close enough, it's a knife. It's a straight knife. I know, pretty gnarly to use a knife as a ruler, but it's going to work until I find my ruler. Okay, there's the first line. Second line starts at -1, which would be down here, and it's going to be up 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3, and there we go. Got those two there. Okay, now obviously they're parallel, but I knew they were parallel because of the same slope. Because some could argue that eventually they'll intersect, but never. So the answer is no solution. Okay, that was pretty easy. Let's take a look. Oh, I found my ruler. What do you know? Let's take a look at something different. Example 2. Okay, example 2 is not going to be as obvious. Okay, so example 2 is a negative x minus 4y equals 10 with an x plus 4y equals negative 10. Okay, all right, now I could graph it, but yesterday we learned about the addition multiplication method, or by the elimination method. Okay, so elimination. Elimination method. So what I'm going to do is, I notice the negative x, positive x, so I'm just going to add these two, and the x's cancel. So if we add straight down, go negative x plus x is nothing, cancels. Negative 4y plus 4y, oh, nothing. Negative 10, everything canceled. So I get 0 equals 0, or everything cancels. Well, if everything cancels, that means it's got to be the same line. It has to be the same line. So same line. If it's the same line, then it's going to look like this picture here. And if I know the answer, I don't need to graph it. I already know the answer. It's the same line. It's infinitely many solutions. Or I like the answer is all real numbers. But I like the cursive R for that symbol. Okay, that's what I like. How am I doing? Okay. All right, that wasn't too bad. Let's take a look at a second example. Okay, turn the page. All right, let's look at example 3. Okay, example 3. Okay, example 3 is going to be a negative x plus a 2y equals 4 and a 2x plus y equals 3. Okay, so I'm thinking let's just solve it. I'm going to, x's are lined up, y's are lined up, equal signs and numbers. So I'm going to do it the way I did yesterday. I'm going to use the multiplication, addition, elimination method. So what I notice is if I can make this a negative 2x, they'll cancel. Negative 2x, 2x. So I'm going to multiply this equation by a positive 2. And that'll cancel out the x's. I could have multiplied this by negative 2. All right, anyway, 2 would make a negative 2x. I like this. So let me rewrite equation 1 and equation 2. So equation 1 now becomes a, you ready? It's a negative 2x. It's a positive 4y equals 8. Equation 2, I'm not going to do anything to it because I want the x's to cancel. So I'll keep it a 2x plus a y equals a 3. Okay, now I'm going to solve. So if I were to do the addition method or elimination and add them now, my x's cancel. 4y plus a 1y makes a 5y. 8 plus 11 is 8 plus 3 is 11. Okay. Divide by 5. Divide by 5, and y is, let's see, my calculator, it's going to be a 2.2. Okay. 2.2. Okay, now 2.2 is a y value, so I'm going to plug it into either this y here or this y. This y looks easier, doesn't it? Let's put the easier equation, so I'm going to put the 2.2 right into here. So I'm going to rewrite equation 2. Instead of 2x plus y equals 3, I'm going to write 2x plus, putting 2.2 right in here, plus 2.2 equals 3. I'm going to solve minus 2.2 minus 2.2. So I got a 2x equals, let's see, that's a 0.8. All right. 0.8 and then I'm going to divide by 2, and I get a 0.4. Now, okay, great example. So here's my answer. It is 0.4 comma 2.2. This is a great example of why we don't want to always graph all these, why it's better to use a different method than graphing, because the answer I had is a point of intersection, but you would never get these two answers by graphing. But to get the exact answer, I did the math, I got an exact answer. Okay, the graphing wouldn't get you that. Okay, so this had one solution, and the one solution was 0.4, 2.2. All right, let's turn page. All right, I've got one more example. All right, last example. Let's see what we got. Okay, so I've got a y equals a 2x minus 5, and I've got a 4x minus 2y equals 10. Okay, so here's what I could do. 1, I could graph it. I don't want to do that. 2, I could use substitution. Yeah, maybe, because I got y equals. Or 3, I could bring the x over and use the addition method. I think I'm going to use substitution because I have what y is equal to, and I'm going to plug that in for y. So when I do substitution, I like to write them side by side. So we write this: y equals a 2x minus 5. My little squiggly in between. I've got a 4x minus 2y equals 10. And I'm going to do my substitution. Okay, so then y is equal to 2x minus 5. So instead of writing y over here, I'll put in my 2x minus 5. Okay, so I've got a 4x minus 2, but not y, but y is equal to. So instead of writing y, let's write 2x minus 5 equals 10. Okay, now I can solve for x. Let's just do some math. 4x, distribute, and go negative 2 times 2x makes a negative 4x. Negative 2 times 5 is positive 10 equals a 10. Okay. 4x minus 4x. Wait a minute, there's no x's. And I get 10 equals 10. Wow, no x, so I can't solve for x. So either the answer is parallel or the same line. But because I got 10 equals 10, these two have to be the same line. So it seems as if my answer has to be all real numbers, or like the book likes, infinitely many solutions. Okay, keep it up, because these grades are going to go in the grade book next week. And when they do it at the end of the chapter, if you haven't been doing it, you're going to have a bad grade. It's really going to take your grade book down. But if you've been doing them, it's going to take your grade up, because these are going to go as a test grade. So here's what I want you to do for today's homework, and keep doing it and keep sending me. Now, if you have any questions, please, if you have any questions at all, please text me, and I'll go through those when I videotape. Okay? So here's our homework for today. Page 140. I want you 1 through 19 odd. Odd is like 1, 3, 5, 7, 9, right? Okay. All the way through the story problem, and then with the story problem, I'll let you think about the fact that maybe it's you have savings, so that you have income is you have $15 plus your $5 per week, and your friend is going to make income by having $25 plus $5 a week, and I'll let you figure it out from there. So good luck. Keep sending me your texts and your homework, and you'll keep getting good grades, and I'll maybe see you someday. Okay, take care and be well.